Hi everyone. Let's practice computing definite integrals using geometry. Let's start by expressing the following definite integral in terms of a, b, and c, where a, b, and c represent positive areas in the graph below. If you would like to try this exercise on your own, stop the video now. You can also download these notes using the link in the video description. The definite integral from 0 to 4 of f of x dx gives us the signed area between the graph of the function f of x and the x-axis. Signed area means that the areas above the x-axis are taken positively and areas below the x-axis are taken negatively. This means that this definite integral can be expressed as a plus c, both of these areas are above the x-axis, minus b, because the region B must be taken negatively. In the next problem, we must this time evaluate the integral from 0 to 5 of f of x dx, where f is as in the following graph, and we can assume that the curve under the x-axis is a semicircle. If you would like to try this problem on your own, stop the video now. I will use the same approach as before. I will look at the areas above the x-axis and I will add them, and I will look at the areas below the x-axis and I will subtract them. I see two areas above the x-axis, this area and this area. I see one area below the x-axis. Let me call it by c. In this case, this definite integral is equal to a plus b minus c. I can in fact compute this time what a, b, and c are. I believe a is the area of this region. This region can be thought of as this rectangle and this triangle. The area of this rectangle is 2. The area of this triangle is 2 times 1/2, which is also 2, which means 2 plus 2 gives me 4. Area of A is 4. Now, the area of B is 1 times 1 times 1/2. That gives me 1/2. Because the region below the x-axis is formed by a semicircle, and I know that the formula for the area of a circle is pi r squared, I know that the area of this half circle will be 1/2 pi r squared. Because in my case the radius is 1, this gives me 1/2 pi times 1 squared. 1 squared is simply 1, which gives me 1/2 pi. Because that area is below the x-axis, I'm subtracting it and I get negative 1/2 pi. If I simplify it, I get 4.5 minus 1/2 pi. Let's try another problem. We must evaluate the following definite integral, where f is the following function. If you would like to try this on your own, stop the video now. We are not given a graph, we must produce the graph ourselves. We know that this function has the formula x for x's between 0 and 2. The function is f of x equal to x between 0 and 2. When I draw it, this is what I get. The function has the formula 3 for x's between 2 and 4. The function f of x equal to 3 looks like the following. And I draw it between 2 and 4. To compute the definite integral from 0 to 4 of f of x dx, I simply add the area which I will call by the letter a to the area which I will call by the letter b. Area A is 2 times 2 times 1/2, which gives me 2. Area B is 2 times 3, which is 6. 2 plus 6 is 8. This definite integral evaluates to 8. I have one more problem for us to try. This time, we must evaluate the following definite integral. If you would like to try this on your own, stop the video now. This is slightly more complicated because you might not know how to draw this function. However, I believe you know how this function looks like. You might just not recognize it right away. To solve this problem, to evaluate this integral, you must recall the formula for the unit circle. The equation of a unit circle centered at the origin is given by x squared plus y squared equals 1. I believe you must have seen it before. If you solve this equation for y, you get, first you subtract x squared on both sides, and you get y squared equals 1 minus x squared. And then you take a square root, and you get that y equals plus or minus square root of 1 minus x squared. This is the same thing as saying that y has two formulas. It has the formula square root of 1 minus x squared and negative square root of 1 minus x squared. This makes sense. When you draw a unit circle, you get an upper half of a unit circle and a lower half of the unit circle. Note that the positive square root describes the upper part of the circle, and the negative square root describes the lower part of the circle. Now, our integrand is the lower part of the circle, which means to compute this definite integral means to compute this area. Let me denote that area in orange. Because the area of a circle is given by pi r squared, and we know that r is 1 in our case, the area of the entire circle is pi. We are concerned with half of that area, so we are concerned with 1/2 pi. Because this area or this region is below the x-axis, this integral from -1 to 1 of negative square root of 1 minus x squared dx must equal negative pi over 2. The trick here was to recognize this formula as the formula describing the bottom part of the unit circle centered at the origin.